Hello and welcome. This is Jim Compton, Rankin Technical College. This video is about a review of JavaScript fundamentals. So I create these quick guides last semester. Last semester for an HTML JavaScript course. So here's some basic fundamental JavaScript guides that I'm going to go ahead and use in this video just to kind of do a quick review. Okay. I also down here at the bottom, I added a couple, actually just today, I added a couple advanced topic ones for arrow functions and hoisting, and we'll take a look at them as well. Okay. I'm not going to go through all of these. So the students in this course, this is a second year course. This is part of this review is part of a second year course, right? So you've all done C#, you've been through HTML and JavaScript, and you've done C#. So you've got some programming experience under your belt now, right? So we're going to just kind of come back because I know a lot of you haven't probably done any JavaScript in maybe even a year, because it might have been your first course that you did at Rankin, and then now you've done some other courses since then. So we're going to go back and just kind of review a few things. Some of these areas I probably won't go too much into, kind of like conditional statements, else, if else, switch statements. Not that it's not important, and there are some variations between this and say C#, but the basic understanding of conditional statements you probably already understand because you've been doing it that more than just one course, right? But JavaScript have some specific things that are kind of exclusive, kind of different with JavaScript than it is with other C# and other programming languages. Okay. So I won't go through like conditional statements, probably not through the loops and that, but I will go through some of these other ones and really kind of start with some of the basic stuff just to kind of review. Okay, so let's start out here with JavaScript variables. And so, what is a variable? So with JavaScript, you can declare variables using var, let, and const. Okay, here's just some examples of some basic declaring of variables with those different with var, let, and const. Variable names. Variable names must follow specific rules, right? They must start with a letter, either underscore or uppercase or lowercase, A through Z, underscores or dollar signs. Okay, you cannot use hyphens. It can contain a letter. It can contain digits 0 through 9, underscores or dollar signs. It cannot start with a number though. Okay, it is case sensitive. Most of you, know that from the C# and other things you've done as well. Cannot use reserved keywords, like in this case for JavaScript, class, function, return. Cannot use keywords. So here's some valid variable names. Camel case here, you use an underscore here. You're starting it with a underscore, that is valid. With a dollar sign, starting the variable name with a dollar sign. Here you're just including numbers. Here you got an underscore, all uppercase with underscore, right? So these are some invalid ones. Actually, maybe I should make this just a little bit bigger here so you can see this well. Invalid variable names. So here you're starting with a number. Okay, can't do that. This one contains a hyphen. Can't do a hyphen for a variable name. This one contains a space. Can't use a space. And this is a class as a reserved name, reserved keyword. Can't use that. Okay. So naming convention tips: camel case for variables and functions. Pascal case. Okay. Pascal case is where you've got the uppercase for, if it's a kind of a different, like here you got, these are like 3 different words, my, class, and name. This is using Pascal case, right? Upper snake case, right? Max value, okay? That could be used for constants, very popular, a good reason to use constants. Now, back in the day, before there was the let and const keywords, ways to define variables, you only had var. So a lot of times all the constants would always have, uppercase and use underscores so that you could look at a variable and say, oh yeah, this is a const, right? This is a constant. But with nowadays, if it's you're using the constant, right, keyword for your variable declaration, you can tell just by that, oh yeah, this is a constant. But it's still kind of good practice, I think, to still use all this uppercase, use this format as well, even with your constant, so it sticks out very quickly, and oh yeah, this is a constant. Always use descriptive names. You don't want to just use like X and Y and Z. You want to use like the here username, because you might write some code later on. Somebody else might come in to edit your code, and they'll appreciate if you use names that were descriptive of your variables. And even for yourself, you might write something and you might come back 3-4 months later, and you have to kind of refamiliarize yourself with the code again, because if you didn't use descriptive variables, right? So var, let, and const. So var is considered function scoped. So if you create a variable, if you create a var, a variable within a function, okay, anywhere within that function, even if you create that variable within a block of code, say an if statement, or within maybe a for loop, right? Or any kind of loop, if you declare that variable within there, right, then it is available within that whole function, okay? So, that can be kind of dangerous sometimes if you're manipulating things. A lot of times if you declare something within a block of code, or a loop, there's a reason that you declared it inside of there, right? You kind of wanted to do something, and then when you're done with that loop or that block of code, you don't need that variable anymore, right? Obviously, if you define it at the upper level of the top level of the function, then you kind of want it to have that later on, right, within your function. But if you declare something within anywhere within your function, it's always going to be available, okay, when you use var. So var is considered function scoped. It can be redeclared, right? And this is one of the things that kind of is bad about JavaScript, and using the var keyword, right? Using var for declarations, it can be redeclared. So you can say that var username equals Ted. Then you can say the next line, you say var username equals Lucy, right? You did the whole redeclared the variable completely, right? You can do that with a var, right? Can be updated. So once you say var username equals Ted, then you could just say next line down, say username equals Lucy, right? And that's fine, right? Hoist it to the top. Okay, and we'll talk about, maybe I'll go ahead and get into hoisting here a little bit. We'll switch over to that just for a minute. But it's hoisted to the top, okay? And here's just a note that it's also a legacy, pre ES6, right? Like pre 2015, right? This is kind of legacy way, right? These others are the more modern way, right? Let and const. But let's just talk about hoisting a little bit. Let me go to that guide. I know this is, just want to talk about this really quickly. And maybe we'll delve into this a little more later. But what hoisting is, hoisting is JavaScript's default behavior for moving declarations to the top of their scope before code execution. It's as if JavaScript lifts your variable or function declaration to the top of the current scope. Okay, so think of it as a classroom where your teacher takes attendance at the start of class. Before any lesson begins, the teacher knows who's supposed to be there, even if some students haven't arrived yet. JavaScript does something similar. It scans your code and registers all declarations before running any code. Okay. Key point: only declarations are hoisted, not initializations. Okay. Let me just kind of going to skip down here a little bit. What hoisting really means: when we say declarations are hoisted, does not mean that JavaScript engine rewrites your code or physically moves lines of text to the top of the file. Okay. Instead, it means the memory is allocated for variables and functions before the code is actually executed. Okay. The code stays exactly where you wrote it. All right. JavaScript just knows about the declarations ahead of time. Okay. So I don't want to get here. We'll go talk about it a little bit here, and then I'd rather come back to this. I don't want to kind of get stuck on this. So there's two phases of execution. To understand hoisting, you need to know that JavaScript processes your code in two distinct phases. Okay, this two-phase process is the key to understanding why hoisting works the way it does. So phase one is the creation phase. Okay, it's memory allocation. Before running any code, JavaScript scans through your entire script and allocates memory for all declarations it finds. Okay. And like I said, I don't want to spend too much time on this. I'll come back to this later and we'll talk about this a little more in depth. But that's phase one, is the memory allocation phase. And then there's the execution phase. Okay. Now JavaScript runs your code line by line. Okay. And assigns given values, function calls are executed, expressions are executed, and your program logic runs in order. Okay. So, but why it matters is during the creation phase, hoisting can work different for different variables, right? Variables declared with let, so variables declared with var are registered and set to undefined. That's not the case with let and const. Variables declared with let and const are registered but left uninitialized. Okay. All right. So we'll come back to this later. Just kind of wanted to give you a little bit of background about hoisting since it came up in that other guide. Okay. So let's get back to this. So let is block scoped, right? So basically for a var, which is function scope, like I said, you can define it within a block, you can define it within a loop. Then when you leave that loop or that block within that function, it is still available. Okay, it's still available, but not for a let. Let is block scoped. Okay, so if you define a let within an if statement or a loop, once you leave that block, once you leave that if statement or that loop, that variable is no longer available. Okay. It cannot be redeclared, right? So you cannot go let username equal Ted and then the next line go let username equal Lucy, right? You cannot do that. You can do that with a var. You cannot do that with a let. And the same with const. So we might as well cover that as well. Okay. Const is also block scoped and also cannot be declared. Okay, so these first two are the same between let and const. Now a let can be updated. So you can say let username equal Ted, and then the next line down, right? You can't redeclare it again, but you can say username now equals Lucy, right? Username equals Lucy, so you can update that, right? With a const, you cannot update that. Okay, not initialized when hoisted. Okay, then we were talking about hoisting. It's not initialized when hoisting. Okay, and like I said, we'll talk about hoisting more in the future. I don't want to get stuck on that too long. Okay, we'll get. I want to make sure that you really do understand hoisting, and I think it's very important, especially when you start looking for a job in the area. Having a good understanding of some of these, more advanced. Hoisting is important. I wouldn't say it's an advanced topic, but, probably a lot of junior people don't understand hoisting. It's probably a very good idea for you to understand it. But for let, it's not initialized when hoisting. For a const, it must be initialized. Okay, it must be initialized. And then the let and const are both considered more, you know, are part of the more modern JavaScript specifications, right? So here's a comparison table. Kind of, we went through all of this already, right? Here's the different scopes: redeclaration, reassignment, hoisting, right? They're all hoisted, but it all depends, you know, it's a little bit different, right? Initial value required. No, you don't have to give it initial value for a var or let, but for a const, you can't just define a variable and not give it a value, right? You must initialize it. So here's some examples. Got x equal 10, and now you got x equals 20. That's good. You can do that, right? You can redeclare it. For let, once you do here, you're doing a y equals 10, right? Obviously, like I said earlier, using x and y's are probably not best, right? You should use something that kind of defines what you're doing, but that's okay. People with numbers, you know, you see that a lot more, right? But here you got a let y equals 10, and now you're saying you cannot do this. You cannot do let y equals 20, right? This is okay though, right? Const cannot be updated or redeclared, right? So once you defined your constant, okay, you cannot do this, and you cannot even reassign a different value, right? Oh, you know, I'll point this out, and it's important to understand. You know, we'll kind of discuss this again later. So for like an object, if you create an object called person and you give it the name John, right? You can do person.name equals Jane. So you can you can make changes within the object, right? But you cannot reassign the person object, right? You cannot reassign this object like this. You're reassigning this to an empty object. You can't do this. But you can change what's inside of the object, okay? Okay, global scope, this is just showing you if you define something at like top of your file, it's available within the function itself. Obviously, as best practices, you want to avoid this in every case you can. You really don't want to have a global scope of a variable that can be modified, right? And in most cases, you can avoid this. But there are some certain instances where, you know, it makes more sense, right? All in all, if you're setting a variable equal to something that's never going to change, you should always use a constant. Okay, you always use a constant if you know that variable is never going to change, right? So here's showing the function scope again. Variables declared with a var are scoped to the function they're declared in, right? So here's a var, and it's just showing that you cannot access this outside the function, right? Here, you're showing that within a block, these are letting const block scope. So here you got an if statement, right? And so the only one that's going to be available outside of this if statement is your variable, your var, right? This one will be available. These two will not, right? They're not accessible outside of block since they're block scoped. So best practices, use const by default. Use it for variables that won't be reassigned. If you know that you're not going to reassign a variable, use const. Use let when you need to reassign. Avoid var altogether. It's outdated and can lead to unexpected behaviors. So, you know, you can define it on top of a file and read that file into some other program, and all of a sudden, you know, you you still got that variable. You're holding on to that variable. You should try to avoid that at all costs. Okay. Declare variables at the top, right? Either if they're going to be global scoped, it's kind of best to go ahead, best practices to define them at the top of your file or the top of your function or whatever, right? Just makes it a little more readable. Instead of just, here, defining it here and then doing some little if statement and declaring another variable, right? You should probably just do it all at the top if that's possible, right? Also initialize variables when declaring. If you already know what the value of it, you should declare that, right? One variable per line. It's easier to read. Some people put multiple variables on the same line. It's kind of really best practice to put one variable per line. Keep scope as narrow as possible, okay? So if you're only going to use it within a if statement, you don't need to define it at the function level, right? You need to define it at the if statement, right? All right. I'm not going to go through, I don't want to spend too much time. Let's just go ahead. This is kind of keep saying this over and over again, but use const for values that won't change. Use let for values that will change, okay? Avoid var altogether as much as possible, okay? Well, not as much as possible. Really, there's no reason for you to use var at all. Variable names must start with a letter, a $sign, or underscore, okay? Let and const are block scoped. Var is function scoped. All declarations are hoisted, but only var is initialized. Okay. All right. So next, let's go ahead and look at data types a little bit here. So data types specify what kind of data can be stored and manipulated within a program. JavaScript is dynamically typed language, meaning variables can hold values of any type without explicit type declaration, right? So this is one of those areas where we are going to be transitioning to TypeScript, right? So there's types within TypeScript, okay, and that helps with making your code more reliable, okay, and we'll get into that here in upcoming videos. All right. So a number. For a number, this is all you do to say you want a variable to equal a number. You just assign it the number, right? Now you say value equals hello. Now it's a string. Now it's a Boolean, right? Well, so there's 7 primitive types: string, number, big int, Boolean, undefined, null, and symbol. Okay, so you might want to kind of review these because, obviously it's different than what you'd see in C#, right? So primitive data types. So here you've got a string, represents textual data enclosed in quotes, right? And then also there's the templates you can use, right? Using the tick. This is not a single quote. This is a tick, right? Which is up there on your keyboard on the left side of the number 1 key, right? You have the tilde, and the tick mark, right? And that key on the left side at the top. Numbers represent both integer and floating point numbers, right? So you're just calling this int, right? This is just the name you're giving it, right? But you could be given this any name, right? Big int represents integers, larger, yeah, really big ones, right? Really big ones. That's for big int. Boolean, either true or false, right? Here's a variable that has been declared but not assigned a value, x, right? That's undefined. Null represents intentional absence of any value. And symbols, we probably don't use them a lot, but they're unique and immutable identifiers often used as object keys. one thing I forgot to mention up here at the top when we started here. So in JavaScript, you can do this, right? But in TypeScript, you cannot. Okay, TypeScript, you cannot. So TypeScript's going to define these as numbers or strings or booleans. Okay, so TypeScript's a little different in that case, right? All right. Let me see what we want to kind of look at here. Not going to really go through all of these, I don't think. You've all have experience using these, especially like in C#, but something close. They're somewhat similar, right? I do want to kind of mention this one here, JavaScript number precision. JavaScript uses 64-bit floating point format, and this can lead to precision issues. So if you take 0.01 plus 0.02, that does not equal 0.03, okay? This is actually what, if you take 0.0 plus 0.12, this will return this. Let me see what will happen in the browser on this. Just use the console in the browser. You're probably going to have to start getting used to that again. So I'm just going to hit the F12 key, and I'm going to go to console here. And as you can see, hopefully you can see that within the video here. So there you go. The same thing, you got the same result as it was mentioned there, right? So here's what you get on that, right? So 0.1 plus 0.2 does not equal 0.3, right? All right. Type checking. So you can do type of on anything. Obviously, for something like this, you're putting it in here. That's a string and that's a number. But you can do the same with a variable, type of a certain variable as well, right? So type of null returns object. Okay. So this was a thing that kind of got created in JavaScript from the beginning. And just for backward compatibility and everything, they've always kind of left that in the specification. So if you do a type of null, null was an object, was created as an object in original versions of JavaScript, and they've kind of just always left that in there. Okay. So to check for null, you need to check if your variable equals null, right? So better type checking methods, right? The triple equal sign, right? Value equals null. Check for not a number. You can do not. Number is not a number. If it's not a number, it'll return true. Here's how you can check for undefined, right? Implicit conversion. So JavaScript does automatically converts types in certain situations. So if you've got if you have a string, a 5 define, a 5 as a string, and you add 3 to it, it's going to treat this as a string. It's going to do what's called string coercion. It's going to actually convert this to a string and add it to the 5, so it will be 53, right? And here you got a string, you're adding a Boolean, right? You're adding a Boolean to it. So you'd end up also getting a string. It'll say hello true, just like that. So in this case, though, actually what this will do here, because with this, you know, plus sign can be used. Plus sign can be used for concatenation, right? So what this is kind of doing is concatenating this. You've got a string and you're concatenating. Well, minus doesn't really have a, you know, this is not a concatenation. So in this case, what this will actually do, this will do a number coercion, right? So it's going to convert 5 to a number and then do 5 minus 3. Let's go take a look at that real quick. And let's bring up developer tools here and just drop that in there, right? And so that you can see there, the answer is 2, right? Yeah, let's look at that one. So we're there. And so it'll multiply it. Okay, it's going to do a number coercion on those strings. So here's one true plus 1. Okay. True becomes 1. False becomes 0. Yeah, so that's another thing. And we'll go into more of that here as well about falsy and truthy with JavaScript. Right? But actually, you know, true becomes 1. You know, in this case, when you're adding a Boolean, a number to a Boolean, true is going to become 1, for 1 is true, false is 0. Okay. Boolean coercion, if hello, right? So this is that idea of truthy and falsy. So if you've got a value, right? In this case, you're saying if hello, right? If it's a value, yes, it's a value of hello, this is going to convert to true. But since you're using an if statement, if is expecting this to be evaluated to a true or false, right? So if you have a value in there, it's considered true. Okay. If you have a 0 in here, it's considered false. Right. Not that you would really do this in some cases. There are some cases where, you know, you're going to learn with when we start doing like React and that, we'll be using some truthy and falsy stuff. Okay. And it'll be a little different. Okay. But for right now, let's keep it simple. And like I said, this is actually going to return a true. This is going to return a false. Okay. This, even though it's an empty array, it's still considered truthy. It's still considered something, right? It's something. It's an empty array, but it's something, right? So this returns actually true. Explicit coercion, conversion. So yeah, this is one way to define a string, and then toString. Yeah. To number, you parse int. So you take a parse int. So this will convert a number to a you know, a string of numbers to a actual number, right? This parse int will take a string and convert this to a number. Parse float, okay, that will you know, take a string and parse that into a floating point number, right? Just remember, if you have a floating point number and you do a parse int on there, it's going to truncate, right? It's going to truncate your decimal place. Okay. Oh yeah, and this is a unary plus. Yeah, just by using a plus before that, that's going to convert that into a number as well. Not that I really ever done that. I don't know. I guess some people do, but all right. To Boolean. So Boolean 0 is false. A Boolean 1 is true. A Boolean empty string. All you got, if you put a space in here, though, it's going to become false. Let's just do that real quick. Let's see. Okay. So we just put that in there. That's going to return false. But, okay, if we put in a space in here, this is going to return true. And automatically, developer tools automatically kind of does it. without you hitting the return key. But so the Boolean with an empty space is considered something. It's an empty space. It's a right. It's a space. It's something. It's true. Here is just completely empty, nothing. Right. This would be false, whereas this is true. Okay. Truthy and falsy values. So falsy values convert to false. So false itself, a 0, a negative 0, right? A big int, this little n here signifies it's a big int. Using 0 and then the signification of it being a big int, 0n, okay? That's going to return false, falsy, right? Empty string, null, undefined, and not a number. All of these will return false, and they're considered falsy values. Truthy values, obviously true. Any non-zero number, right? Any non-zero number, 1 through whatever, right? Any non-empty string, right? Non-empty string. Yeah, you put that like that, that's going to return true, right? Because it's got a value. From a JavaScript perspective, this is a value of 0, right? But a string of 0, right? It's a string. Here's false. This is also a string, right? Even though a false over here is going to be return false, falsy value. If you use a string of false, it's a value, so it's going to return true. An empty array is going to return true. An empty object is going to return true, and then any function that you know, if you pass a function into a if statement, right, it's going to return true as well. Okay. Equality comparisons. So this a double equal sign is loose equality, right? So here it will do type coercion. Okay. When you use 2 equal signs, it's going to use type coercion. Okay. If needed, right? It's called loose equality, right? So in this case, 5 equals 5, right? Use 2 equal signs. Let's go take a look at that, all right? And then we'll do the false one while we're there. So let me, helps if I hit the right key. So I'm just hitting F12 to open up developer tools, all right? So that's true. If I go ahead and change this to a triple equals, right, it's going to return false. Okay. So that was the first one. And then obviously triple equals called strict equality. Okay. Checks type and value. Does it do type coercion? Type coercion is where JavaScript under the hood kind of converts things for you if it makes sense to convert it, right? If it's possible to convert it, so to speak. Whereas when you use 3 equal signs, that's strict equality, right? So in this case, does 5 equal 5 the string? No, it does not. It's false. And same thing with not equal sign. This is loose inequality, right? So in this case, is 5 not equal to 5? No, it is equal to 5. So it's going to return true, false, right? This is 5. This does equal this when you use just 1 equal sign. Okay. Here, strict inequality, when you use the exclamation point and then 2 equal signs, that is strict inequality, right? Does it do type coercion? No, it does. Conversion? No, it does not, right? And then in this case, is 5 not equal to 5? Yes, it's not equal to 5, right? So that's true. All right. Let's go down here. So use constant let, avoid var. Yeah, we kind of discussed that already in the previous guide. Use strict equality, right? Prevent type coercion bugs. Another one that, I'll mention now is it's easy, and, you've all had experience with C# and that. So you're used to, equal sign and a double equal sign. Sometimes, especially it's in In C sharp, you know, it's going to kind of catch some things because it's you know, it's a typed, right? It's not dynamically typed, right? Whereas JavaScript's dynamically typed, and so sometimes you can be doing some things that's not even going to complain about it, right? So, you know, thing that's a common error is using the assigning something instead of checking for equality, right? You know, you need to do at least two equal signs for equality, right? To assign something, you just use one equal sign, right? So, but always use strict equality when you can. Be explicit with type conversion. Don't rely on implicit coercion. Yeah, you should probably, if you're wanting something to be a number, you need to convert a string to a number before using it. That's best practices, right? Don't let JavaScript do it on its own, and especially when we start doing TypeScript, you're not gonna be doing that in implicit coercion like that, right? So check types when necessary. Use type of for checking. So if there's something that's getting passed around and it gets passed into your function, you may want to check, hey, what is this? Is this a number or is this a string before you do anything with it? Remember, primitives are immutable. String methods return new strings. Okay. Handle null and undefined. Check before using the values. Beware of floating point precision. So yeah, there's some libraries. So when we looked at point 0.1 plus 0.2, it does not equal 0.3, right? There are libraries you can use for precise calculations, right? Use descriptive variable names, indicate the type. Use number is not a number, is more reliable than is not a number for checking not a number. All right, always initialize variables, avoid undefined variables when possible. Okay. Okay. Just in summary here, JavaScript has seven primitive types: string, number, big int, Boolean, undefined, null, and symbol. Primitives are immutable and compared by value. Each primitive type has its own case and behavior. Use type of for basic type checking, but be aware of its quirks, especially with null. So if you recall, null is, if you do a type of null, it's going to return object, right? It's one of those early bugs in JavaScript that they've kind of left in there, I guess, for just backward compatibility. Understanding truthy and falsy values for conditional logic. Always use strict equality, triple equal sign, to avoid type coercion surprises. Be explicit when type conversions when needed. Remember, not a number is equal to itself. All right. All right. So that's that. I'm not going to go, well, we can open this up. What are functions? Obviously, your experience in C Sharp is similar with as far as the methods are concerned. I'm not going to go through all of these. I would, this is just using the basic function, more the traditional function. I do want to go through the arrow function though. Okay. So I suggest you come in here and take a look at these just for a quick review on your own. Okay. Let me close some of the stuff out here. It's kind of cluttered here quickly. All right, so let's just come down here and look at JavaScript arrow functions. So arrow functions are a more concise way to write functions. So this was introduced in ES6 back in 2015. They use the equal sign greater than, right, arrow syntax instead of the function keyword. Think of them as a shorthand way to write functions that make your code cleaner and more readable. So why use arrow functions? Shorter syntax. They have an implicit return. One-line functions return automatically, okay, instead of having to say return this, return that. in a normal JavaScript function. They have implicit returns, cleaner callbacks. They're a perfect way for array methods like map, filter, and for each. Modern standard, used extensively in modern JavaScript and frameworks. So they're very helpful and useful in using TypeScript, and also with when we start doing some React stuff in this course as well. Basic arrow function syntax. Arrow functions replace the function keyword with an arrow that comes after the parameters. So here's your parameters. This is the syntax. You got your parameters. Here's your arrow. And then here's your code to execute. So here is a traditional function. Sometimes, in some cases you'll say, well, it didn't make much of a difference, but in a lot of cases it will be a lot shorter. Okay, but here's a traditional function. Okay, use the function keyword, say hello, right? And here is your function, traditional arrow function. Okay, so say hello equal to, since you have no parameters, you're just defining this say hello. This say hello is equal to this, which is just going to print out a console log. Right? Both are called the same way by just saying say hello, open and close parentheses. So here's arrow functions with parameters. So here you've got a function with a parameter of name. Here you just go ahead and you put name in your parentheses, right? And use this arrow function like that, okay? Here is an arrow function with multiple parameters. Passing in A and B, this returns A and B. Pretty straightforward on that. So arrow function shortcuts. Arrow functions have several shortcuts that make your code even more concise. These shortcuts are one of the main reasons developers love arrow functions. Single parameter, no parentheses needed. Okay. So down here is a, with parentheses, always valid. You can put, right, if you just have one parameter, you can put it in parentheses, but you don't have to, right? So this here is the same as this, right? Just doesn't have the parentheses. So implicit return, no braces are return keyword, right? When your function body is a single expression, you can remove the curly braces and the return keyword, and the value is returned automatically, right? So here is a one with an explicit return, right? Or you can write it like this. You don't have to include the return. You don't have to, and you don't have to include the curly braces as well, right? So this is going to automatically, this is an implicit return. This is automatically going to return, okay? It's going to basically, you're passing in a number, right? Well, it's right down here. You're passing in a number. This is that number, and you're going to take that number, you're going to multiply it by 2, and you're going to put that value into double here, right? Or, well, that's back into number, I'm sorry. So this will return, this will return the value of 5 times 2, which is 10, right? More examples of implicit returns, okay? So here you're doing what? Square is x, right? So as long as you got that one value, you don't have to put it in the parentheses, right? So a lot shorter than doing a function, a traditional function. Multiple parameters with implicit return. You don't. So here you got multiple. Okay. Since you have multiple, you have to use the parentheses, right? But you don't have to use the return type, right? You don't have to use the curly braces or the return, right? That was add. This is multiply. This is doing a max, right? No parameters, empty parentheses required. Yeah. So if you have no parameters, you must use empty parentheses. Okay. So I know that can be a little confusing, but um, that's just kind of required there. So if you don't have any parameters, you have to at least put something there, right? If you have one, you can use it without the parentheses, or you can include it with the parentheses. Here's some examples of get a random number, and here's get a current year. So syntax summary, parentheses, no parameters. This is a no parameter. You must, if you have no parameters, you must include the parentheses. A single parameter, no parentheses. All right. Here is the optional. If you want it within parentheses, you can do that as well. If you have multiple parameters, you must have it within parentheses, right? Oh, yeah, if you have multiple statements. So if you're just doing something simple, that's just a simple statement, one statement, you know, you don't have to have that in braces, curly braces. But if you've got multiple statements, you have to have it in curly braces. Returning objects. When return an object literal with implicit return, you must wrap it in parentheses. This is because curly braces are interpreted as function body, not an object. So JavaScript thinks your parentheses is the function body, right? Because JavaScript objects also use the curly braces, right? And from a JavaScript perspective, it was think that this is the function body and not an object, okay? So the correct way to do it for an object is you still use your curly braces, but you wrap that in open and close parentheses, okay? Here is a shorthand for objects. You can also, instead of using the named, the name and the age parameters like this, you can just go ahead and pass in name and age like that, right? All right. Common gotchas. Forget to wrap the return object in parentheses is a very common mistake. If your arrow function returns undefined, when you expect an object, check if you need to add parentheses. So side-by-side comparison. So here's your traditional function. We kind of already looked at this, but this is arrow functions. And, when you got some of these simpler ones, it's you don't save a lot. But when they get a little more complex, a little bit, you can make you can definitely make a much more concise using an arrow function. So obviously here with the traditional function, and you only got one parameter, you don't have to use their parentheses here at all. And like I said, it's always going to automatically return going to return the value, right? Implicitly. All right. Yeah, one thing I do want to point out is for hoisting. A traditional function can call before declaration. You can call a traditional function before it's even declared. So like, you can actually be calling it before you even declare the function at all, right? But for an arrow function, you must declare it before calling that, right? So that's definitely something you have to watch. Some people will put all their functions at the bottom of a file or something, right? That's fine for a traditional function, but it's not fine for an arrow function. So for a traditional function, it has its own this, okay? Where an arrow function inherits this from the parent. And we will, if you don't understand that, we will look at that more in depth later on, okay? But just remember that this is done a little differently for an arrow function than it is a traditional function, okay? And I'm going to review the whole arrow function stuff again because it can be a little tricky, especially if you're not, it's been a while since you even did regular functions, regular JavaScript functions, and, arrow functions might be a lot newer for you. So definitely want to kind of really get that down, really get arrow functions down and understand them. So traditional functions are best for methods and constructors, where arrow function is best for callbacks and short functions. So real quick, what is a callback? So a callback is simply a function that is passed as an argument to another function and is then executed or called back at a later time. Okay, think of it like leaving your phone number with a restaurant and they'll call you back when the table is ready. Right? So why callbacks matter? Customization. Let function behave differently based on what you pass it. Okay, reusability, write generic functions that work with any callback. Asynchronous operations like handling events and timers and data fetching. Sometimes you want to go fetch some data, and when that data gets done, you want to call a function from that. Okay, and callbacks are the way to do that, right? Array methods. There's powerful methods like map, filter, and for each, right? And them are power methods and a very good use for callbacks. So here's a basic callback example. Okay. You're passing in a number, you're passing in a callback, right? This function accepts the callback. So this is a name and this is a callback, right? And then you're executing the callback, right? And then you're getting the result, you're passing back you're logging the result. So different callbacks we can pass in. So here we can pass in a double, right? We can pass in, so we're passing in some arrow functions, right? We're passing in a double. Here we're passing in a square or an add 10, right? So different callbacks we can pass in, right? So basically you maybe want to check if your number is, some, depends on what you're trying to do, I guess, right? So in this case, you could pass in a double, a square, or add 10. So here you want to process a number, passing in it as a double, passing in as a square, passing as add 10, right? So that way, if you're going to be doing different things, you can just write one method, right? You can write one method, one function, right? And then by passing in your callback, it's going to return different value. Inline callbacks, anonymous functions. Instead of defining a callback separately, you can define it directly where it's needed. This is called an inline or anonymous callback. Okay, so here's a traditional function as an inline callback. All right, and here's an arrow function as an inline callback. Much more concise. Okay, gives you the same result. Real world callback examples, event listeners, right? Event listeners are very basically our, arrow functions, our callbacks, right? Event listeners. So you basically going to add an event listener, right? And then it's going to sit there until some event happens, and then it's going to execute what's in that, right? And in this case, you're adding an event listener of a click, so it returns when the button is clicked, right? So here's the callback runs. So here's a set timeout. And so the callback runs after 2 seconds, right? Here's a set interval, and this is going to run every 1 second, right? It's going to run every 1 second. Let's just go ahead and drop this in there. And you can do that for all these. Invalid or unexpected token. Oh, that's because That's because I did that incorrectly. 2 seconds have passed. 2 seconds have passed. Right? So there's a little delay there. All right. Here, we're going to do the set interval. Let me grab that one. And all of these examples that are in here, you do the same thing. Just check them out, test them. Another second, another second. It's going to keep doing this for like ever. All right. We come back in here. See, it's going to still do it. So actually, I'm going to have to kill my browser because of this. I knew it. I knew it when I started it because you're doing that interval there, right? I'm going to come back here. I'm just going to see 24 times it's already executed that, right? So I'm going to just actually close this and okay. Array methods. So here you've got an array of numbers. Here is a for each on numbers. For each is a very useful function to call on numbers. So on an array. So for each number, right? You're logging each number here, right? So you for each one, this is just a loop. It's going to print out 1, 2, 3, 4, 5, right? The callback transform each element, right? Double numbers.map, right? Transform each element. And here the callback test each element, right? Filter. So you're basically filtering the callback test each element, and it's going to, you're going to pass in each number, right? And you're going to run the filter on each one. Maybe we'll just go ahead and let's drop that in here too. And then what were we wanting to do on this one? What was I doing on this? So even if it's not there, numbers still should be there. It should still be in memory. Once you do a variable like that, it's still there, right? There you go. So just to let you know, once you drop something in here, even if you leave and come back, right? Close in and come back, it's going to stay in memory until you hit refresh. When you hit refresh, numbers are going to be gone, right? From the console here. I wonder why that's doing like that. That's kind of surprising because I know numbers is there. It must be how the browser how the JavaScript engine handles that. All right, that's all right. Don't want to get stuck on that. All right, so callbacks and arrow functions. Arrow functions are perfect for callbacks because of their short, clean syntax. Instead of writing that function, you can just write x arrow x times 2. All right, arrow functions with array methods. So do a for each. Arrow function much cleaner. Maps for transforming array elements. And we'll look into all these more in the future. Just kind of want to go through a few of these. So you have map, right? For each, a map, filter, find. You also can do a find, okay? Reduce, calculates a single value for something. Chaining array methods. All right, I don't want to, we will come back through these. I just wanted to kind of give you at least a little bit of an introduction here. Let's just kind of go through these though real quick. Arrow functions provide a shorter, cleaner syntax, right? Single parameter parentheses are optional. A single expression returns an implicit return is implicit, right? You don't have to use the return keyword, right? Returning objects, you need to wrap that in parentheses, okay? Arrow functions are perfect for callbacks and array methods. Don't use arrow functions for object methods or constructors, okay? Arrow functions are not hoisted, okay? You need to declare them before using them. Arrow functions don't have their own this, okay? We will go into this more in the future, okay? And like I said, basically all the stuff for arrow functions, we will spend some more time. You're not going to learn everything in one day, so we will revisit this again later on, okay? Just wanted to kind of give you at least a little bit introduction of this, and so at least you can kind of start grasping some of these concepts, and we will build upon that as we go along. Okay, next thing I want to go through. I want to go through, I think, let's go through objects a little bit. Custom objects, okay? So what is object-oriented programming? You should all know what object-oriented programming is by now. So object-oriented programming is a programming approach that organizes code around objects, reusable software components that combine data, properties, and functionality, methods into a single unit. So 3 types of JavaScript objects. You have your native objects, okay? These are built into JavaScript, like array, date, math, string, okay? You have host objects. These are provided by the browser, okay? These are provided by the browser, such as window, document, form, etc., right? Now, we'll be doing a lot of stuff that, we'll be doing some stuff that, is not always going to be using Node. Nodes, we're going to be using Node in this class. And so Node is all about using JavaScript on the server side. So, for many years, JavaScript was only used on the client side, right? Within the browser, right? And stuff we're looking at right now is really just all browser-based kind of JavaScript, right? But Node actually came along, I think, 2009, and that started with bringing JavaScript onto the server side. So you can actually create JavaScript on the server side, deployed on a server, right? And so when you're doing that, you're not going to have, so Node would still have access to the native objects, right? But it's not going to have access to host objects, right? Because it doesn't have a browser, right? Node's about server side, not about browsers. So just kind of want to point that out. So, but the 3 types of JavaScript objects, basically from the perspective of a client-side JavaScript is the native objects, right? The host objects, which is a window, a document, a form, right? So actually, if we go over here and do an F12 again, if we just put in window here and hit enter, and we go ahead and expand this is basically the window object, okay? This is all within the browser. This is always available in the browser, right? Doesn't matter if you're using JavaScript or not JavaScript, you just come into a console, put in a window, boom, you're going to have all this. This is all built into the browser, right, by default. So this is all the different functions and methods that are available to the window object, right? It's substantial, all of this, right? Some of these look familiar. An alert, right? Remember an alert, doing an on blur event, right? There's lots of different things in here that, kind of used often, right? But you also see what history you have, right? History of different sites. So like if within a browser session, if you went from one thing to another within that session, right? Once you close it, that history is gone for that, right? But this is that browser, the history of the browser, right? So right now, my history length is 1, right? If I come in here and go to me just go to another thing here. I got some of the C# thing there. Let me go to that. Let's kind of go back a little bit. All right, now we're back here again. Now if I go to window, and let's go down to history. So now you can see history's 3, right? So this is holding on to all of that, right? If you dig down far enough, right, you can get that. So on focus, here's on focus, you know, lots of different things, right? Lots of different things. On click, on change, on click, all these different ones, right? So these are all considered, these are the host objects, right? It's available in the browser. Custom objects, right? And remember, custom objects you create on yourself, right? So the idea encapsulation means that all code and data needed for an object are combined within an object itself. The code and data are hidden, so they can't accidentally be modified by other programs. So objects expose an interface, the properties and methods that other programs can access and use, right? An object literal is a standalone object created for a single purpose. So here's an object literal where you got a person, you give it a name, an age, a city, right? So this is just a basic object. You've assigned all the values. So, you know, it's not really good for reuse, right? But this is, and that's why it's saying for a single purpose. So, but you know, you may have other kinds of things that are, makes sense that to have that, right? But, you know, in a case like this, you know, obviously, you know, you want something where you can generate ones, right? So in this case, you've got excess properties with dot notation. So you define it as person, person.name is going to return John, person.age returns 30. You can access properties with a bracket notation, right? So you can do person and then use the bracket and name. That's going to also return John. So these are 2 different ways to return the same name, okay? So here's bracket notation, allows variables, property names. So here you defined a property of city, right? And then pass in prop into this, and this will return New York here, okay? Obviously, you can still do the same thing you did for name and age. You can do person.city, right? But this is just stating this is a different way using, allows variable prop names, okay? So here's a nested object where you've got employees, okay? And you have a nested object of address as well, right? So to access the city here, you would go employee.address.city, okay? Adding methods to object literals, okay? Object with methods. So here's your object of calculator, and you're adding a method of add, a method of subtract. Here's a method of reset, right? So then you have access to all these different methods that you created within this object using dot notation. Calculator.add, right? You can grab all this, try this out, and try this out, drop this in Visual Studio Code if you'd like, or, you know, you can drop it right into the console in the Chrome Developer Tools, right? This keyword inside an object named this refers to the object itself. Use this to access the object's properties and methods, right? Modern method syntax, right? Let person name equal Bob. No need for a function keyword, okay? You can just do greet like this. You can create another function, say age, right? You don't need to use a function keyword. This is kind of a shorthand method syntax for functions. Okay. Creating objects with a new object. You can also do this as well, creating a new object that way, and then add properties to it, right? Add properties to it. You could also add a method. So person.greet, right? Here you're adding a function to it, a method, right? Limitations of the object literals. Object literals are not reusable. If you need multiple similar objects, use constructor functions or classes itself instead. Object classes and constructor functions. An object class is a template for creating multiple similar objects. You define a class using a constructor function. Okay. So basically, here's a constructor function for person objects. Passing a name value. And I'm sure you've all seen, you're familiar with this from C#. Somewhat similar, right? JavaScript's different, but, some of the basic concepts are still there, right? And you'll have to watch that. Sometimes especially you're getting used to doing a lot of C# stuff, and then you come back and try to do some JavaScript stuff. It's different a little bit, so you'll have to be cognizant of that. So create a new instance. So here you create a new instance of person, passing in John and 30. Here's a new person, passing in Alice and an age of 25. And you can call the greet function like that. So naming convention, constructor function names traditionally start with a capital letter to distinguish them from regular functions, right? So here's a constructor for a car object, right? Here's all your properties, and here's your functions that you're creating, right? Different way to write functions, right? This way you actually use the function keyword. Combining object classes. So here's like a card, a deck, and a shuffle. Yeah. All right, yeah, it's kind of a little complicated. You can play with this, though. I'm not going to walk through all this right now. But so in JavaScript's different because JavaScript does not, we talk like inheritance, it's not class-based. So, C# is strictly and, fundamentally class-based, right? So object-oriented, it's an object-oriented programming language, right? Unlike JavaScript, where classes are, what classes, you can write classes with JavaScript, and what they're kind of called is, in the industry, what classes are called in JavaScript is called the syntactic sugar over prototypes. So because JavaScript is considered a prototype language, it uses prototypes. Really, it's not class-based, right? And C# classes are the primary building blocks for the entire language. Even though you can do, a little bit of small things without classes, but you essentially cannot really write a C# program, anything sophisticated enough without using classes, right? So in C#, a class acts as a blueprint. You define the blueprint once, then you create multiple instances, right? Whereas, JavaScript is a little different, JavaScript uses what's called for inheritance, right? So for C#, inheritance uses the classical inheritance. Classes inherit from other classes. It's different in JavaScript, where inheritance, it uses, for JavaScript, inheritance, JavaScript is prototype based, and it uses what's called a prototype chain. So objects link to other objects, all right? It's different, all right? So for JavaScript, classes are optional, right? You can just make objects on the fly with JavaScript. It's all dynamic, right? Whereas C#, it's not dynamic, right? It's more rigid. If it's not in the class definition, you can't add it, right? JavaScript's very flexible. There's good and bad in that, right? There's good and bad in there. So every object has a prototype, right? A template containing properties and methods shared by all instances of the class. Using prototypes is more memory efficient than putting methods in a constructor. So, it's kind of built based on, using it inside of a browser, really. So, a lot of what's happened with JavaScript is to make it very memory efficient, easy to use, like within a browser, right? So adding methods to prototypes. So here you've got a function, right? You create this function, right? And then you can go ahead and say, I want to add these methods, into this, right? So I do person.prototype.greet, right? So now I'm actually adding methods to prototype shared by all instances, right? So once I do this, then I could go ahead and instantiate it multiple times, and it's going to have this greet function available, right? So here it's doing a greet function. Here it's doing have birthday. So here you creating an instance. John equals a new person. You're just passing in name and age for both John and Alice. You do a john.greet, right? Hello, I'm John. Here you're doing Alice, have birthday, happy birthday. Now 26 years old, right? So a different way to do things, right? Adding methods to prototype, right? You have to use this prototype to do this, though, right? Person.prototype.greet. You're adding that, and that's available to all. So very dynamic. Why use prototypes? It's very memory efficient. Methods defined once, shared by all instances. Easily updates. Change prototype method to update all instances. Better performance, less memory used per object. Okay. Extending built-in objects, right? Which you want to, before we say anything here, caution here. Extending built-in prototypes can cause conflicts with other code, but it's just mentioning that you can actually do that, right? Which is kind of scary. So, like in other languages, you ain't going to be able to do things like that. It's very, but then JavaScript, there's a lot of flexibility, and, you can actually add a method to array prototype, right? You can change how some certain functions that are already available work, right? Let's talk about closures here a little bit. So a closure is created when a function remembers the variables from its surrounding scope, even after that scope has finished executing, right? So here you've got a basic closure example. So you've got an outer loop and you have an inner loop, right? Not loop, but an outer and an inner function. So here's your outer function. It's basically the whole function. Here's your inner function, right? So in this case, you creating a new outer, right? And then you can do this counter stuff. And then count is private, can't be accessed directly, right? Count is private, it can't be accessed directly, right? We'll spend some more time with closures later. Do want to kind of talk about public, private, and privileged methods a little bit. So here's a public method defined on the prototype, accessible from outside the object. Okay. So here's a public method. Anyone can call it. Bank account.prototype get balance. Right. Here, so what you did was this balance equals balance, right? So this is available. Here, if you're doing this, define inside a constructor, accessible within the constructor, using the let, right? So this is actually, from a perspective object, this is only going to be available, right? It's only going to be available within the constructor itself, okay? Here, you're using a private, right? This won't, so this here, this won't work. Can't access the private method, all right? That's all about scope, right? Privilege methods. Now, when you define, so you still have your private variable here, right? But here, if you use this, right, you can access these private variables, right? You can access this private variable. You get the balance, right? These methods will have access to this private variable. Kind of like C#, just it's a little bit different, right? You know how you define private variables, and then you can have then you have different methods that can return those variables, gets, getters, and setters, and so forth, right? So, but JavaScript is a little different though, right? But here's your private method that you created. You don't state it's private, right? It doesn't have private keywords. But here you've got a balance. This is not accessible unless, only accessible by your methods that have access to this. By using this keyword here, right? It has access to this, the instance of this object, right? So you can call get balance, and then it will return the balance, right? It will return the value of your private variable. So there you go down here. And if you want to play around with these, like I said, you can just drop these into Visual Studio Code, or, you can also put these within the console of the Chrome Developer Tools as well. So I'm not going to, we're going to go into this more, I promise. I just wanted to kind of give you a little bit, kind of more of a review, and maybe this is a little beyond a review. So we will go ahead and, go through a lot of this stuff again. I just kind of wanted to get you primed a little bit. So some key takeaways here. Object OOP organizes code into reusable objects. Object literals are for single-use objects. Constructor functions create reusable classes. This refers to the current object, which I'm sure you all know that from already taking C#. Prototypes share methods efficiently. Closures create private variables. Public methods are on prototype. Private methods are inside a constructor. Privileged methods access private data. Okay. Prototype chains enable inheritance. All right. Etc. here. Like I said, we'll go through this stuff again. I just kind of want to give you quick little, just kind of wake things up for some of the concepts. Just start get you thinking about these things again. Okay. So that's all I have here for this. We're going to start working on our transition from JavaScript into TypeScript. And when we do that, we will come back into some of these concepts again, but we'll do it from a TypeScript perspective, okay? But it's still good to understand, kind of review some of these concepts again, at least the basic stuff, variables, data types, right? Your operators, conditional statements, loops, and you can go ahead and come in all these different guides and take a look at these, okay? So that's all I have, and have a great day. Thank you.